Table 250.66 addresses the sizing of grounding electrode conductors. It's crucial to understand that the table dictates the minimum size of the conductor required for bonding, and this size is dependent on the size of the service entrance conductors or the equivalent size for parallel conductors, but it isn't based on bonding a metal water pipe to a ground rod. The application dictates how the table is used. When dealing with metal water pipe bonding, it's essential to consider the size of the water pipe itself, not just the presence of a ground rod. Here's a breakdown of how to interpret Table 250.66 in relation to grounding electrode conductors. Firstly, locate the size of your service entrance conductors or equivalent for parallel conductors. Secondly, once the conductor size is determined, read across the table to determine the minimum size grounding electrode conductor required, usually copper or aluminum. When a metal water pipe is used as a grounding electrode, it must be supplemented by an additional electrode. This supplemental electrode can be a ground rod, among other things. However, the bonding of the water pipe is subject to specific rules outlined in the National Electrical Code. The size of the grounding electrode conductor to the water pipe is determined by Table 250.66 based on the size of the service entrance conductors. If the water pipe is the only grounding electrode, then the grounding electrode conductor must be sized according to Table 250.66 based on the size of the service entrance conductors. For a supplemental electrode, such as a ground rod, the portion of the grounding electrode conductor that runs to the ground rod only needs to be 6 AWG copper. It is important to understand the difference between the grounding electrode conductor and the bonding jumper . The grounding electrode conductor connects the service equipment to the grounding electrode system. The bonding jumper, on the other hand, ensures electrical continuity and low impedance between metal parts that are likely to become energized. Now, let's clarify some common misunderstandings. It is incorrect to assume that a number 4 AWG conductor is always sufficient when bonding a metal water pipe to a ground rod. The minimum size of the bonding conductor is determined by the size of the service entrance conductors or equivalent size of parallel conductors feeding the service. The statement that if the water pipe is 1 inch or less in diameter, the bonding conductor must be at least number 6 AWG, and if the water pipe is larger than 1 inch in diameter, the bonding conductor must be at least number 4 AWG, is a simplification and does not take into account the size of the service entrance conductors feeding the service, or the requirements if the water pipe is used as part of the grounding electrode system. Always consult the latest edition of the National Electrical Code and relevant local amendments for precise requirements and definitions. When sizing grounding and bonding conductors, consider these crucial factors. Firstly, the size of the service entrance conductors dictates the minimum size of the grounding electrode conductor according to Table 250.66. Secondly, if a metal water pipe is used as part of the grounding electrode system, it must be supplemented by another electrode. Thirdly, the bonding jumper for metal water piping and other metal piping systems must be sized according to 250.104. Also keep in mind that local amendments to the National Electrical Code may exist. These amendments may impose stricter requirements. Always verify and comply with local regulations. Remember that proper grounding and bonding are paramount for electrical safety. Incorrectly sized conductors can compromise the effectiveness of the grounding system, increasing the risk of electrical shock, fire, and equipment damage. It is always recommended to consult with a qualified electrical professional for specific guidance on grounding and bonding requirements in a particular application. A qualified electrician can assess the specific electrical system, considering factors like service size, grounding electrode system, and local codes to ensure compliance and safety. Here's a detailed explanation of the key terms and concepts involved. Firstly, the grounding electrode is a conducting object through which a direct connection to earth is established. Common examples include ground rods, metal water pipes when supplemented, and concrete encased electrodes used for grounds. Secondly, The grounding electrode conductor connects the service equipment, e.g., service panel, to the grounding electrode. This conductor carries fault current to the earth, facilitating the operation of overcurrent protective devices, e.g., circuit breakers, fuses. Thirdly, the bonding jumper is a conductor that connects metal pots to ensure electrical continuity and create a low impedance path for fault current. Bonding jumpers are used to bond metal water pipes, gas pipes, and other metal components within a building. The National Electrical Code (NEC) provides comprehensive rules and guidelines for grounding and bonding. It's crucial to understand and adhere to these requirements to ensure electrical safety. Table 250.66 dictates the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. The larger the service entrance conductors, the larger the grounding electrode conductor must be. Ground rods are typically used as supplemental grounding electrodes. The portion of the grounding electrode conductor that connects to a ground rod is generally not required to be larger than number 6 AWG copper. Metal water pipes, when used as grounding electrodes, must be supplemented by another type of electrode. This requirement ensures redundancy in the grounding system. Bonding metal water pipes and other metal piping systems is essential to prevent electrical shock hazards. Bonding creates a low impedance path for fault current, allowing overcurrent protective devices to quickly clear faults. Improperly sized grounding and bonding conductors can compromise the effectiveness of the grounding system. This can lead to increased risk of electrical shock, fire, and equipment damage. Local amendments to the National Electrical Code may impose stricter requirements for grounding and bonding. Always verify and comply with local regulations. Consulting with a qualified electrical professional is always recommended for specific guidance on grounding and bonding requirements. An electrician can assess the specific electrical system and provide tailored recommendations. Consider the following scenario. A building has a 200 amp service. The service entrance conductors are number 3/0 AWG copper. According to Table 250.66, the minimum size grounding electrode conductor for 200 amp service with number 3/0 AWG copper service entrance conductors is number 4 AWG copper. Now, suppose the building has a metal water pipe that is used as a grounding electrode, supplemented by a ground rod. The grounding electrode conductor connecting the service equipment to the water pipe must be at least number 4 AWG copper, based on Table 250.66. The portion of the grounding electrode conductor that connects the water pipe to the ground rod only needs to be number 6 AWG copper. Bonding jumpers are used to bond the metal water pipe to other metal components in the building, such as metal gas pipes or metal conduit. These bonding jumpers must be sized according to 250.104, based on the size of the service entrance conductors. It is important to distinguish between the grounding electrode conductor and the equipment grounding conductor. The grounding electrode conductor connects the service equipment to the grounding electrode system. The equipment grounding conductor, on the other hand, connects the metal enclosures of electrical equipment to the grounding system. Equipment grounding conductors provide a low impedance path for fault current, allowing overcurrent protective devices to quickly clear faults. The size of the equipment grounding conductor is determined by 250.122 based on the size of the overcurrent protective device protecting the circuit. In summary, understanding grounding and bonding requirements is essential for electrical safety. Always consult the National Electrical Code and relevant local amendments for specific guidance. When in doubt, consult with a qualified electrical professional. Let's further clarify the concepts using different scenarios. Firstly, consider a residential dwelling with a 100 amp service. The service entrance conductors are number 4 AWG copper. According to Table 250.66, the minimum size grounding electrode conductor for a 100 amp service with number 4 AWG copper service entrance conductors is number 8 AWG copper. If this dwelling has a metal water pipe used as a grounding electrode, supplemented by a ground rod, The grounding electrode conductor connecting the service equipment to the water pipe must be at least number 8 AWG copper. The portion of the grounding electrode conductor that connects the water pipe to the ground rod only needs to be number 6 AWG copper. Secondly, consider a commercial building with a 400 amp service. The service entrance conductors are 500 kc mil copper. According to table 250.66, the minimum size grounding electrode conductor for a 400 amp service with 500 kc mil copper service entrance conductors is number 2 AWG copper. If this building has a metal water pipe used as a grounding electrode, supplemented by a ground rod, the grounding electrode conductor connecting the service equipment to the water pipe must be at least number 2 AWG copper. The portion of the grounding electrode conductor that connects the water pipe to the ground rod only needs to be number 6 AWG copper. Also note, in this scenario, 250.66 would require a minimum 4 AWG copper connection to the ground rod. It is also important to consider the material of the grounding electrode conductor. Table 250.66 provides minimum sizes for both copper and aluminum conductors. Aluminum conductors must be larger than copper conductors to provide equivalent ampacity. For example, a number 4 AWG copper conductor has approximately the same ampacity as a number 2 AWG aluminum conductor. When using aluminum grounding electrode conductors, be sure to select the appropriate size from table 250.66. Corrosion can be a significant concern for grounding and bonding conductors, especially in damp or corrosive environments. Use appropriate connectors and fittings to prevent corrosion. Protect conductors from physical damage. Grounding and bonding conductors should be installed in a manner that protects them from physical damage. Avoid running conductors in areas where they are likely to be damaged by impact or abrasion. Regularly inspect grounding and bonding systems to ensure that they are in good condition. Look for signs of corrosion, damage, or loose connections. Correct any deficiencies promptly. Proper documentation of the grounding and bonding system is essential for future maintenance and troubleshooting. Keep records of conductor sizes, materials, and installation methods. This documentation will be invaluable for future electrical work. Consider the following advanced topics related to grounding and bonding. Firstly, impedance grounding is a type of grounding system that uses an impedance G resistor to limit the ground fault current. Impedance grounding is often used in industrial and commercial applications to reduce the magnitude of ground faults and minimize equipment damage. Secondly, isolated ground receptacles are a type of receptacle that has a separate grounding conductor that is isolated from the normal equipment grounding system. Isolated ground receptacles are often used in sensitive electronic equipment to reduce noise and interference. Thirdly, equipotential bonding is a technique used to minimize voltage differences between different metal parts in a building. Equipotential bonding is often used in swimming pools, spas, and other wet locations to reduce the risk of electrical shock. These advanced topics are beyond the scope of this general overview, but it's important to be aware of their existence. When designing or installing complex electrical systems, consult with a qualified electrical engineer to ensure that all grounding and bonding requirements are met. Grounding and bonding are not just about meeting code requirements. They are about protecting people and property from electrical hazards. By understanding the principles of grounding and bonding and following the requirements of the National Electrical Code, we can create safer electrical systems for everyone. Proper grounding and bonding also protect sensitive electronic equipment from damage due to voltage surges and other electrical disturbances. A well-designed grounding and bonding system can significantly improve the reliability and performance of electrical equipment. When troubleshooting electrical problems, always check the grounding and bonding system first. A faulty grounding or bonding connection can cause a variety of electrical problems, including voltage fluctuations, equipment malfunctions, and electrical shocks. By thoroughly inspecting the grounding and bonding system, you can often quickly identify and resolve electrical problems. In addition to the National Electrical Code, other standards and guidelines may apply to grounding and bonding systems. For example, the IEE Institute of Electrical and Electronics Engineers publishes standards for grounding and bonding in industrial and commercial power systems. Consult with a qualified electrical engineer to determine which standards and guidelines apply to a particular application. Grounding and bonding is a constantly evolving field. As new technologies and materials emerge, the National Electrical Code is updated to reflect the latest advancements. Stay informed about the latest changes to the National Electrical Code and other relevant standards to ensure that your grounding and bonding practices are up to date. In conclusion, mastering the art and science of grounding and bonding is a continuous journey. By staying informed, seeking expert guidance, and adhering to the highest standards of safety, you can ensure the integrity and reliability of your electrical systems. The information provided here is for general educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrical professional for specific guidance on grounding and bonding requirements in a particular application. The complexity of electrical systems necessitates a thorough understanding of these principles to mitigate risks effectively. A well-grounded and properly bonded system is the cornerstone of a safe and reliable electrical installation.